Hello, this is Tyler here. We are going to discuss about blockchain and the transformation it's having on our society today. What is blockchain? This is a seemingly complicated question, and it's actually much more simple than most people realize. At its core, it's very simple. Blockchain is a type of database. To be able to understand blockchain, it helps to first understand what a database actually is. A database is a collection of information that is stored electronically on a computer system. Information or data in databases is typically structured in table format to allow for easier searching and filtering for specific information. What is the difference between someone using a spreadsheet to store information rather than a database? Spreadsheets are designed for one person or a small group of people to store and access limited amounts of information. In contrast, a database is designed to house significantly larger amounts of information that can be accessed, filtered, and manipulated quickly and easily by any number of users at once. And large databases achieve this by housing data on servers that are made of powerful computers. These servers can sometimes be built using hundreds or thousands of computers in order to have the computational power and storage capacity necessary for many users to access the database simultaneously. While a spreadsheet or database may be accessible to any number of people, it is often owned by a business and managed by an appointed individual that has complete control over how it works and the data within it. How does a blockchain differ from a database? Firstly, storage structure. One key difference between a typical database and a blockchain is the way that data is structured. A blockchain collects information together in groups, also known as blocks, that hold sets of information. Blocks have certain storage capacities, and when filled are chained onto the previously filled block, forming a chain of data known as the blockchain. All new information that follows the freshly added block is compiled into a newly formed block that will then also be added to the chain once filled. A database structures its data into tables, whereas a blockchain, like its name implies, structures its data into chunks or blocks that are chained together. This makes it so that all blockchains are databases, but not all databases are blockchains. The system also inherently makes an irreversible timeline of data when implemented in a decentralized nature. When a block is filled, it is set in stone and becomes part of this timeline. Each block in the chain is given an exact time stamp when it is added to the chain. Now, what is decentralization? For the purpose of understanding blockchain, it is instructive to view it in the context of how it has been implemented by Bitcoin. Like a database, Bitcoin needs a collection of computers to store its blockchain. For Bitcoin, this blockchain is just a specific type of database that stores every Bitcoin transaction ever made. In Bitcoin's case, and unlike most databases, these computers are not all under one roof, and each computer or group of computers is operated by a unique individual group of individuals. Imagine that a company owns a server comprised of 10,000 computers with a database holding all of its computers' account information. This company has a warehouse containing all of these computers under one roof and has full control of each of these computers and all the information contained within them. Similarly, Bitcoin consists of thousands of computers, but each computer or group of computers that holds its blockchain is in a different geographic location, and they are all operated by separate individuals or groups of people. These computers that make up Bitcoin's network are called nodes. In this model, Bitcoin's blockchain is used in a decentralized way. However, in this model, Bitcoin's blockchain is used in a decentralized way. However, private, centralized blockchains where the computers that make up its network are owned and operated by a single entity do exist. In a blockchain, each node has its full record of the data that has been stored on the blockchain since its inception. For Bitcoin, the data is the entire history of all Bitcoin transactions. If one node has an error in its data, it can use the thousands of other nodes as a reference point to correct itself. This way, no one node within the network can alter the information held within it. Because of this, the history of transactions in each block that make up Bitcoin's blockchain is irreversible. If one user tampers with Bitcoin's record of transactions, all other nodes would cross-reference each other and easily pinpoint the node with the incorrect information. This system helps to establish an exact and transparent order of events. For Bitcoin, this information is a list of transactions, but it also is possible for a blockchain to hold a variety of information like legal contracts, state identifications, or a company's product inventory. In order to change how that system works, or the information stored within it, a majority of the decentralized network's computing power would need to agree on set changes. This ensures that whatever changes do occur are in the best interest of the majority. Transparency. Because of the decentralized nature of Bitcoin's blockchain, all transactions can be transparently viewed by either having a personal node or by using blockchain explorers that allow anyone to see transactions occurring live. Each node has its own copy of the chain that gets updated as fresh blocks are confirmed and added. This means that if you wanted to, you could track Bitcoin wherever it goes. For example, exchanges have been hacked in the past where those who held Bitcoin on the exchange lost everything, while the hijacker may be entirely anonymous. The Bitcoins that they extracted are easily traceable. If the Bitcoins that were stolen in some of these hacks were to be moved or spent somewhere, it would be known. Is blockchain secure? Blockchain technology accounts for the issues of security and trust in several ways. First, new blocks are always stored linearly and chronologically. That is, they are always added to the end of the blockchain. If you take a look at Bitcoin's blockchain, you'll see that each block has a position on the chain called a height. As of November 2020, the block's height has reached 656,197 blocks so far. After a block has been added to the end of the blockchain, it is difficult to go back and alter the contents of the block unless the majority reach a consensus to do so. That's because each block contains its own hash, along with the hash of the block before it, as well as the previously mentioned timestamp. Hash codes are created by a math function that turns digital information into a string of numbers and letters. If that information is edited in any way, the hash codes change as well. Here's why that's important to security. Let's say a hacker wants to alter the blockchain and steal Bitcoin from everyone else. If they were to alter their own single copy, it would no longer align with everyone else's copy. When everyone else cross-references their copies against each other, they would see this one copy stand out and that hacker's version of the chain would be cast away as illegitimate. Succeeding with such a hack would require that the hacker simultaneously control and alter 51% of the copies of the blockchain so that their new copy becomes the majority copy and thus the agreed upon chain. Such an attack would also require an immense amount of money and resources, as they would need to redo all of the blocks because they would now have different timestamps and hash codes. Due to the size of Bitcoin's network and how fast it is growing, the cost to pull off such a feat would probably be insurmountable. Not only would this be extremely expensive, but it would also likely be fruitless. Doing such a thing would not go unnoticed, as network members would see such drastic alterations to the blockchain. The network members would then fork off to a new version of the chain that has not been affected. This would cause the attacked version of Bitcoin to plummet in value, making the attack ultimately pointless as the bad actor has control of a worthless asset. The same would occur if the bad actor were to attack the new fork of Bitcoin. It is built this way so that taking part in the network is far more economically incentivized than attacking it. Bitcoin versus blockchain. The goal of blockchain is to allow digital information to be recorded and distributed, but not edited. Blockchain technology was first outlined in 1991 by Stuart Haber and Scott Stornetta, two researchers who wanted to implement a system where document timestamps would not be tampered with. But it wasn't until almost 2 decades later, with the launch of Bitcoin in January 2009, that blockchain had its first real-world application. The Bitcoin protocol is to build on a blockchain. In a researcher paper introducing the digital currency, Bitcoin's pseudonymous creator Satoshi Nakamoto referred to it as a new electronic cash system that's fully peer-to-peer with no trusted third party. The key to understand here is that Bitcoin merely uses blockchain as a means to transparently record a ledger of payments, but blockchain can in theory be used to immutably record any number of data points. As discussed above, this could be in the form of transactions, votes in an election, product inventories, state identifications, deeds to home, and much more. Currently, there's a vast variety of blockchain-based projects looking to implement blockchain in ways to help society other than just recording transactions. One good example is that of blockchain being used as a way to vote in democratic elections. The nature of blockchain's immutability means that fraudulent voting would become far more difficult to occur. Blockchain versus banks. Banks and decentralized blockchains are vastly different. To see how a bank differs from blockchain, let's compare the banking system to Bitcoin's implementation of blockchain. We're going to discuss some advantages and disadvantages of blockchain. For all of its complexity, blockchain's potential as a decentralized form of record keeping is almost without limit. From greater user privacy and heightened security to lower processing fees and fewer errors, blockchain tech may very well see applications beyond those previously stated. There are also some disadvantages. Here are a few selling points of blockchain for businesses on the market today in more detail. Accuracy of the chain. Transactions on the blockchain network are approved by a network of thousands of computers. This removes almost all human involvement in the verification process, resulting in less human error in an accurate record of information. Even if a computer on the network were to make a computational mistake, the error would only be made to one copy of the blockchain. In order for that error to spread to the rest of the blockchain, it would need to be made by at least 51% of the network's computers, a near impossibility for a large and growing network the size of Bitcoin. Cost reductions. Typically, consumers pay a bank to verify a transaction, a notary to sign a document, or a minister to perform a marriage. Blockchain eliminates the need for all third-party verification, and with it their associated costs. Business owners incur a small fee whenever they accept payments using credit cards, for example, because banks and payment processing companies have to process those transactions. Bitcoin, on the other hand, does not have a central authority and has limited transaction fees. Decentralization. Blockchain does not store any of its information in a central location. Instead, the blockchain is copied and spread across a network of computers whenever a new block is added to the blockchain. Every computer on the network updates its blockchain to reflect the change. By spreading that information across the network rather than storing it in one central database, blockchain becomes more difficult to tamper with. If a copy of the blockchain fell into the hands of a hacker, only a single copy of the information rather than the entire network could be compromised. Efficient transactions. Transactions placed through a central authority can take up to a few days to settle. If you attempt to deposit a check on Friday evening, for example, you may not actually see the funds in your account until Monday morning. Whereas financial institutions operate during business hours, 5 days a week, blockchain is working 24 hours a day, 7 days a week, and 365 days a year. Transactions can be completed in as little as 10 minutes and can be considered secure after just a few hours. This is particularly useful for cross-border trades, which usually take much longer because of time zone issues and the fact that all parties must confirm payment processing. Private transaction. Many blockchain networks operate as public databases, meaning that anyone with an internet connection can view a list of the network's transaction history. Although users can access details about transactions, they cannot access identifying information about the users making those transactions. It is common misperception that blockchain networks like Bitcoin are anonymous, when in fact they are only confidential. That is, when a user makes public transactions, their unique code called a public key is recorded on the blockchain, rather than their personal information. If a person has made a Bitcoin purchase on an exchange that requires identification, then the person's identity is still linked to their blockchain address. But a blockchain, even when tied to a person's name, does not reveal any personal information. Secure transactions. Once a transaction is recorded, its authenticity must be verified by the blockchain network. Thousands of computers on the blockchain rush to confirm that the details of the purchase are correct. After a computer has validated the transaction, it is added to the blockchain block. Each block on the blockchain contains its own unique hash along with the unique hash of the block before. When the information on a block is edited in any way, that block's hash code changes. However, the hash's code on the block after would not. The discrepancy makes it extremely difficult for our information on the blockchain to be changed without notice. Transparency. Most blockchains are entirely open source software. This means that anyone and everyone can view its code. This gives auditors the ability to review cryptocurrencies like Bitcoin for security. This also means that there is no real authority on who controls Bitcoin's code or how it is edited. Because of this, anyone can suggest changes or upgrades to the system. If a majority of the network users agree that the new version of the code with the upgrade is sound and worthwhile, then Bitcoin can be updated. Banking the unbanked. Perhaps the most profound facet of blockchain and Bitcoin is the ability for anyone, regardless of ethnicity, gender, or cultural background, to use it. According to the World Bank, there are nearly 2 billion adults that do not have bank accounts or any means of storing their money or wealth. Nearly all of these individuals live in developing countries where the economy is in its infancy and entirely dependent on cash. These people often earn little money that is paid in physical cash. They then need to store this physical cash in hidden locations in their homes or places of living, leaving them subject to robbery or unnecessary violence. Keys to a Bitcoin wallet can be stored on a piece of paper, a cheap cell phone, or even memorized if necessary. For most people, it's likely that these options are more easily hidden than a small pile of cash under a mattress. Blockchains of the future are also looking for solutions to not only be a unit of account for wealth storage, but also to store medical records, property rights, and a variety of other legal contracts. Disadvantages of blockchain. While there are significant upsides to blockchain, there are also significant challenges to its adoption. The roadblocks to the application of blockchain tech today are not just technical. The real challenges are political and regulatory, for the most part, to say nothing of the thousands of hours of custom software design and back-end programming required to integrate blockchain to current business networks. Here are some of the challenges standing in the way of widespread blockchain adoption. Tech cost. Although blockchain can save users money on transaction fees, the tech is far from free. The proof-of-work system that Bitcoin uses to validate transactions, for example, consumes vast amount of computational power. In the real world, the power from the millions of computers on the Bitcoin network is close to what Denmark consumes annually. Assuming electricity costs 3 cents to 5 cents per kilowatt hour, mining costs exclusive of hardware expenses are about $5,000 to $7,000 per coin. Despite the cost of mining Bitcoin, users continue to drive up their electricity bills in order to validate transactions on the blockchain. That's because when miners add a block to the Bitcoin blockchain, they are rewarded with enough Bitcoin to make their time and energy worthwhile. When it comes to blockchains that do not use crypto, however, miners will need to be paid or otherwise incentivized to validate transactions. Some solutions to these issues are beginning to arise. For example, Bitcoin mining farms have been set up to use solar power, excess natural gas from fracking sites, or power from wind farms. Next thing is speed and efficiency. Bitcoin is a perfect case study for the possible inefficiencies of blockchain. Bitcoin's proof of work system takes about 10 minutes to add a new block to the blockchain. At that rate, it's estimated that the blockchain network can only manage about 7 transactions per second, TPS. Although other cryptocurrencies such as Ethereum perform better than Bitcoin, they are still limited by blockchain. Legacy brand Visa, for context, can process 24,000 TPS. Solutions to this issue have been in development for years. and there are currently blockchains that are boasting over 30,000 transactions per second. The next thing is the legal activity. While confidentiality on the blockchain network protects users from hacks and preserves privacy, it also allows for illegal trading activity on the blockchain network. The most cited example of blockchain being used in illicit transactions is probably Silk Road, this dark web website. The website allowed users to browse the website without being tracked using the Tor browser and make illegal purchases in Bitcoin or other cryptocurrencies. Current US regulators require financial service providers to obtain information about their customers when they open an account, verify the identity of each customer, and confirm that customers do not appear on any list known or suspected terrorist organizations. This system can be seen as both a pro and con. It gives anyone access to financial accounts, but also allows criminals to more easily transact. Many have argued that the good uses of crypto, like banking the unbanked world, outweigh the bad uses of crypto, especially when most of the legal activity is still accomplished through untraceable cash. The next thing is regulation. Many in the crypto space have expressed concerns about the government regulation over crypto. While it is getting increasingly difficult and nearly impossible to own something like Bitcoin as its decentralized network grows, governments could theoretically make it legal to own crypto or participate in their networks. Over time, this concern has grown smaller as larger companies like PayPal begin to allow the ownership and use of crypto on its platform. And what's next for blockchain? First proposed as a research project in 1991, blockchain is comfortably settling into its late 20s. Like most millennials its age, blockchain has seen its fair share of public scrutiny over the last 2 decades, with businesses around the world speculating about what the technology is capable of and where it's headed in the years to come, with many practical applications for the tech already being implemented and explored. Blockchain is finally making a name for itself at age 27 in no small part because of Bitcoin and cryptocurrency. As a buzzword on the tongue of every investor in the nation, blockchain stands to make business and government operations more accurate, efficient, secure, and cheap with fewer middlemen.